Hey everyone, VidGames Pete here doing another tutorial here on Halo Infinite Forge. This time I'm going to go through object lists and just kind of do an explanation on what they are, how they can be used. Um, I'm actually kind of picking up where I left off in my last tutorial, which was about area monitors. So we're using the same setup, and let me just kind of explain what's going on real quick. So first thing is we have our object with a boundary, which lets us do our area monitor. And we've got a pointer here and up in the ceiling. And then we've actually got this block up in the ceiling. And we've got that on two different sides. And our node graph is already pretty well set up. A little bit different than where we left off in the last video, but some of the core structure is still here. So we have our object area monitor, and it's checking this area monitor, which is set to the boundary on our vehicle blocker. And then we plug that into a branch to check true or false if it's a player or not, because we don't want to get caught up with issues where some other object goes into the area monitor and now it's triggering when we don't want it to trigger. Um, so that's kind of the core of what's getting everything started. But now instead of just going straight into a transform, which is what we did in our last video, we're actually going to bring in our object lists and then also a for loop. This is pretty common in programming. If you're not, if you don't have any programming experience, that's okay. But I'll kind of explain it as we go. But basically, what we're going to accomplish here is we're going to tell it, instead of just plugging in one object and one destination, and then repeating the entire thing for the second object and the second destination, we can actually plug in multiple objects and destinations kind of into one thing and have it go through each of those in a loop. So that's what we're doing here. So first thing we're going to do is we're going to connect up. We want it on true. So if it is a player, we want it to then connect to our for each object. And what's cool about these is you can plug in a list of objects, and what it does is it'll go one by one down through the list. And I kind of organize my lists like this lately just because it keeps them a little more clean. You can see all four objects. And then if you name your objects, you can kind of line them up and make sure that they're in the right locations. Because what you'll notice here in a minute, we're going to use, when we want to match up this wall with this pointer, we need to use the index number of this object list, which is really just like 1, 2, 3, 4. Um, but we can actually tell it which one to do, and we'll get to that in a second. But so what we're going to do here we're going to plug in our objects, which is our walls. We've got two of them going on, um, and they're up in the ceiling right now. So we actually want to use these bottom pointers that I made to bring them down out of the ceiling. So the first thing is, you got all these right side node connectors. This first one on completion, what this means is it's going to go through and loop through every one of these objects first, and then it will then execute whatever you connect to on completion after all of that's done, which we don't want that in this case. Um, what we want to do is we want to have them actually move our objects before all of them are done. So we're going to leave that one blank. We're going to move down to the next one. So this is execute per object. So it means every time it goes through the loop, it's going to do whatever we're connecting to this on each object. And that's what we want here. So we're going to connect it up to our transform, which actually yeah, we'll come back to that. We may actually switch this up to have it just set the object's position, and I'll show you why in a minute. But for now, we'll do transform. I want to show you what it looks like. Um, Next thing is current object. So what this is saying is whatever object it's on in the list, you can output that current object. So that's what we want to move, because we want it to move first wall one, it'll go through this loop. Secondly, wall two, go through the loop. And then the current iteration is basically sending out a number saying this is what one we're at in the list, whether it's 1, 2, 3, or 4. And where that gets helpful is we need a destination object. Well, how do we tell it to match up with the current or the correct slot on this other object list? Well, that's where we can get the current iteration, and actually we're going to plug it into get object at index. So the current iteration is going to be 1, then 2, then 3, then 4. We're going to put that down here to index. So every time it goes through the loop, it feeds which number of the loop it's in, and then we can tell it to get that same number from our next object list, which is our bottom pointers. And then, so it's going to grab, like, let's say it's on the second loop on this one, it's going to feed that 2 into the index. It's going to come in here, find number 2, and then it's going to send it out the end of this over into our object destination. So this right here should work. Everything's all set up, and I want to show you what it does. And I didn't mention it before, but basically when you walk into this area monitor in the center, it's going to make the walls come down as kind of like a barrier. Um, I don't know if it's really a practical thing to use, but oh, something's not connected right because nothing oh, I didn't walk into it all the way. But see how it came down? Both walls came down when we walked into the area monitor. But notice how they came down one after the other. That's kind of what I was hinting at a minute ago. We may want to switch this up because what it's doing is it's going through the loop one time and then it's taking 2 seconds to bring that wall down. Then it's going through the loop a second time. It's taking 2 seconds to bring the second wall down, which practically wouldn't really. We want them to come down at the same time to kind of have that initial effect. There are times though you would want it to be sequentially done, which um, it won't be too difficult to change this up. What we can do is just grab a, let's see where it's at, set object position right here. So if we say let's actually just delete this transform. We're going to say set the object position on each object, and this happens instantly. And so what's going to happen is the computer is going to be going through these lists instantly because it doesn't have to wait that 2 seconds. So we're going to grab current object, and then what we need here, so right now this is outputting an object, but we need a position. So we actually need another node here, which is going to be get object position. So it's going to send out like the XYZ coordinate. Let's just put that under there to keep it neat. And then relative, in this case, it doesn't matter. So we're going to say false. I'll probably do a tutorial another time that talks about kind of what that relative part means. So at this point, what we're doing is we're saying every time it executes, instantly teleport that object to this position. So let's see what that looks like real quick. So this time I gotta remember to walk all the way into it. I'm gonna see that. There we go. The walls came down instantly when I walked in. Which that's pretty cool. And the nice thing is we didn't have to duplicate all of this code twice just to get it to bring each wall down one time. Now, we do have to duplicate the code if we want to use this list and actually take it back up. But the nice thing is we can just duplicate this part right here because our object lists are they're all set. We can just connect to them with whatever we need. So what I'm going to see if it'll let me copy this without it going everywhere. It doesn't always work, but let's try. I think sometimes it works depending on where you click paste, but oh, that's what I was afraid of. So let's see if we can kind of clean this up. All right, let's just pull stuff over. It's getting all spaghetti on us. we got to fix this so we can even understand what's happening here. But basically, we're going to just do the same exact thing we did before. Bring these guys over. All right, that's better to understand. Okay, so we've got the exact same setup. So what right now, if we triggered this, it would literally just try and teleport it to the same exact position and it wouldn't work. However, we actually don't have it connected to our object list. So let's connect it, but instead of connecting the bottom point, let's connect the top point, which we need to grab right here. So now what it's going to do is it's going to trigger, it's going to run through both objects really fast, and it's going to set their positions instantly to the top point. So now when we run this here in a second, we should be able to walk into the circle, walls come down instantly, walk out of the circle, walls go back up instantly. Let's, as long as we connected everything, that should happen. All right, here we go. Oh, it's not working. Did we not connect something? Oh, you know what? It's because I duplicated everything, but instead I put on object enter again. So um, as is common with me, our thing didn't work because I didn't connect something. All right, I think everything's connected now. So again, we have an on object exited area. That's going to bring everything back down. So we don't actually need all this now. So we actually only had to duplicate our code one time. All right, let's try this one. So we walk into the area and the walls come down, walk out of the area, and they go back up. And so again, you can use this for all sorts of different things. I just thought this was an easy visual, and using those object lists and the loops made this much cleaner, because if we wanted to do the same code without those object list and loops, we'd basically have on object entered area here, setting one side up, on object entered area again, setting a second side up. Then we'd have to do two sets for this, and then think about it too. If we wanted to add, let's say we wanted to do four walls, which I won't do for the sake of time here, but if we had a wall on all four sides of that center area, we could easily at this point just build two walls, put a pointer for top and bottom on both sides, and just plug them in right here. And we wouldn't have to duplicate any of this code at all. It would automatically already be working for um, when you walk in and when you walk out. And so that's what's super cool about these object lists, is you can condense your code down significantly. The other thing is you can use these object lists for other things that aren't even the exact same objects. There's a lot of people, again, way smarter than me, that have already used these to do some of the crazy stuff that they've shown in Forge. But wanted to give you guys an idea of how you can use that to kind of just help out with your code, maybe save you some time, save you some actual memory space as well, because the more code or the more nodes you use, it actually goes into your budget. And so having tons of duplicates is going to cause your budget to build up a lot faster. But anyway, I hope you enjoyed this tutorial. If you didn't get a chance yet to check out the area monitor tutorial, I'd definitely recommend it, because it's a super cool feature of Forge. And anyway, hope you enjoyed it. If you have any questions, feel free to leave a comment, and hope you have a wonderful day.